Okay, there we go. Turn it that way a little bit more. Everybody say hi to Davis. Hi, Davis.
Hi, Davis.
Okay. So the first half, we looked at how to set up matrices. We added them, we subtracted them, multiplied them. So now it gets a little bit more complicated as we figure out how to use these to help us solve problems. Okay, so the first thing that we're going to look at is called determinants on page 4 or 5. We're going to learn what determinants are today and how to use them. So let's read about determinants of 2 by 2 matrices. Faith, could you read that there?
Every square matrix has a number associated with it called its determinant. The determinant of 3, negative 1, 2, 5 can be represented by 3, negative 1, 2, 5.
Okay, let's hold it right there. Look at those two, the way those two are written, and can you notice anything different about those two? I couldn't the first time I looked at this either, but there is a difference between those two. Let me write it up on the board. It might become more obvious as I write it on the board.
DET. Yeah, DET.
Okay, there's the matrix.
Oh, the brackets have little tails. One has a tail, one doesn't.
And there's the determinant. Okay? Do you see the difference? These are brackets and these are what?
Like absolute values.
Yeah, like absolute value lines. Okay? So the brackets indicate the matrix, and this is read as the determinant of this matrix. Okay, so this is the determinant, this is the matrix. And we're going to figure out how to get the determinant here in just a minute. How to determine the determinant in just a minute, right? Think about that. We have to determine what this represents. Okay? So, let's take a look at that. It also has where they write a DET in front of this. We never use that here. We use that, okay? This is another way they note it. But we use that notation here with the straight lines. So if you see the straight lines on a matrix, that indicates we're looking for its determinant, the determinant of that matrix. Okay? Keep going, Faith. What's the next sentence say?
The determinant of a 2 by 2 matrix is called a second order determinant.
Okay, why do you suppose it's called second order? 2 by 2, right? Second is the cardinal term for 2. You guys know the terms ordinal and cardinal? You probably don't. Have you heard those terms before, ordinal and cardinal? Ordinal means just counting numbers, 1, 2, 3, in order. The order of numbers. Cardinal means first, second, third, fourth, fifth. Those are cardinal numbers. Have you heard that before?
Yeah.
Okay. So second is the cardinal number for 2, which is the ordinal number. So second order matrix, or second order determinant, second order determinant. And Faith, you're doing a great job reading, so can you,
I just lost the page.
oh, you lost the page?
What page is that?
We're on page 194. Could you read the key concept of how we find a second order determinant?
The value of a second order determinant is found by calculating the difference of the products of the 2 diagonals.
Okay, so we take the 2 diagonals. There's one diagonal. There's the other diagonal. And product means we do what with them?
Multiply.
Multiply the diagonals. So we've got 3 times 15. And what are we going to do with the products? And 2 times negative 1. What are we going to do with the products, Faith?
Find the difference of them.
Find the difference. Okay, so 3 times 5 is?
15.
And 2 times negative 1 is?
-2.
So this would be plus 2, right? So what is the determinant, the second order determinant for this matrix? 17. Did we do that right? Yeah. That's what it says in the key concept there, right? Okay, so if we just symbolically did this, we would have A, B, C, and D, correct? So we have A times D minus C times B. Or they have B times C, sorry. Doesn't matter. That part's fairly simple, right?
Yeah.
Okay, so if we have let's take a look at a couple examples here. Let's look at example 1. Find the determinant, the value of the determinant of negative 2, 5, and 6, 8. Bless you. Okay, so remember, how do we find the... I'll wait for everybody to finish writing here. Give me a second. Ready to go? Okay, so Elam, how do we find a second order determinant?
We take numbers that are diagonal from each other, multiply those to two or more groups, and
How many groups are we going to have of those here?
here two.
Okay, that's what we're talking about, second order.
We can have it.
2 by 2. So we only have 2 diagonals, okay? And what do we do?
And then we minus the group in which the second number from.
What do we do with the diagonals though?
We minus each other.
What do we do with these
Oh,
numbers?
multiply.
Multiply them. Negative 2 times 8 and 6 times 5, right? And what do we do with those?
Subtract.
Subtract. Find the difference. Okay, so negative 2 times 8 is
Negative 16.
negative 16, and 6 times 5 is,
30.
so we end up with what?
Negative 46.
Negative 46. Okay, yeah, be careful that you do this diagonal first, and then we're going to subtract this diagonal from it.
So it does matter whether which one we're going to subtract.
Would it be the same thing if we went the other way?
Yeah.
If we had
It wouldn't be.
30 minus a negative 16, would we get the same thing? Is subtraction commutative?
No.
Subtraction is not commutative, is it? So we wouldn't get the same thing, we'd get a positive 46. So yes, you got to make sure you go the correct way. Okay? So I want you to do 1A and 1B at the bottom of the page. Should just take you a matter of a minute or so to do both of those if you understand how to do them. Uh-oh. Oh, Davis, you get number 1. Okay, Faith. 1A, what did you come up with for the determinant?
26.
Thumbs up, thumbs down. 26, she said. Okay, good. 1B, Kat, what did you come up with? Did you come up with it yet? I'm sorry. 26, thumbs up, thumbs down.
23. Or 26.
Oh, okay. Okay.
What?
Yeah, I was doing the adding my head, addition to my head, and I couldn't make sure if I like counted it right.
So what did you get?
26.
26, thumbs up, thumbs down? Yeah, 26 for both, okay? Now that was fairly simple, right?
Yeah.
Now we go to third order determinants. Ah! I saw a spring come loose from Sarah's head as she's trying to work ahead over here, trying to figure out third order determinants. No? Springs are all nice and tight in there? Okay. Okay, third order determinants. Third order determinants are going to be in what kind of a matrix?
3 by 3.
3 by 3. Now we have a 3 by 3 matrix, okay? There's two ways that we can do a third order determinant. Okay, one is called expansion by minors. So an expansion by minors, if we have a matrix that's A, B, C, D, E, F, G, H, does it go to I, G, H, I? Yeah, they use I, okay. Okay, and we want to figure out the determinant of it. Okay, so what we can do, I'll wait a minute until you're done writing. Okay, is everybody done writing? No? Okay. Jenny, you ready to go? Okay, so expansion by minors. What we do is we choose one of the rows. It doesn't matter. Generally, we just do it with the top row. So I'm just going to teach you top row. Okay? You can do it with the other rows, but let's just stick with top row. Make it simple. Okay? So on top row, we take the first one in the first column in the first row, and we cross out the column in the row. And we are left with a what?
2 by 2.
A 2 by 2. So that is the minor. Okay, so we're talking A here because we took out the column in the row that represents A. And so we use that as a scalar to multiply times the determinant of a second order determinant of the minor E, F, H, I. Okay? So you guys know how to find the determinant of E, F, H, I, right? E times I minus H times F. Okay, and we take that and multiply it times A. And then we do alternating signs. So this is a plus, this is a minus, this is a plus. So we're going to subtract the next term. Okay, so we take B now, and if we take B and we cross out the row and the column, we're left with DFGI. That is the minor. That's the 2 by 2 minor, the second order determinant minor. Okay, so now in this one you're going to take d times I and g times f. You're going to subtract g times f from d times I, multiply that by b, and then we're going to subtract that from the first term here. Okay, now the third one is the c. The third one in that row is the c. We take out the row and the column. Okay, so c is our multiplier here. Now we're plus again because we're alternating every other plus, minus, plus. Okay, and the minor we're left with is DE and GH. Okay, then we do the math on all that and we come out with the determinant. Let's look at an example here. So if we're going to, I'll put it right underneath, if we're going to evaluate 2, 7, negative 3, negative 1, 5, negative 4, and 6, 9, 0. And we're going to find the determinant, okay? So, our A term is the 2 here. We wipe out the column in the row. Whoops. And we put in 2 here. And now what's the minor we're left with?
5, negative 4, 9, 0.
Good. 5, negative 4, 9, 0. Okay, remember that's a plus. The next one's a minus. And what's our B term?
7.
7. And what's the minor we're left with if we cross out row and column?
Negative 1, negative 4, 6, 0.
Okay, and then our C term is
Negative 3.
negative 3. We're going to add.
So minus
Negative 3.
So just put, yeah, minus 3. We're going to add a negative 3.
And you got negative 9 minus 30. Oh, no.
What's our minor?
Negative 1, 5. 6.
Okay, now we figure out the determinants inside here. 5 times 0 is, 9 times negative 4 is negative 36, so it's going to be plus 36, right?
Yes.
Okay, and that's times 2.
So 72.
Hold on, we'll wait to the next step for that, okay? Negative 1 times 0 is 0. 6 times negative 4 is,
Negative 36 is what you add.
so it's 0 plus,
32. Oh, 24.
isn't 6 times 4 24?
Yes.
I
Yeah.
thought it was.
Okay, times 7.
Yep.
Are you with us, Jenny? We did that times that and subtracted. Okay, so 0 minus a negative 24, so that's 0 plus 24. Okay, then we got minus 3, and then negative 1 times 9.
Negative 9 times, minus
6 times 5 is,
30.
okay, now let's do all this together. 2 times 36 is,
72.
and 7 times 24.
What's that?
7 times 24. 168.
168. Good job of using your calculator. What's negative 9 times negative 30? Or I'm sorry, negative 9 minus 30. Negative 39 times a negative 3.
117.
Is it going to be plus or minus?
Positive.
Plus 117. Okay? Now we do 72 minus 168 plus 117. We come up with what? I'm probably in the way of Davis.
21.
So we got.
Happy birthday, Davis. Late birthday.
Is today his birthday?
No,
Yesterday.
Oh, yesterday.
Happy late birthday!
Yes.
Okay, so we took 5 times 0 got 0. 9 times negative 4 is a negative 36, but we're subtracting the negative 36, so that's plus 36. Here we took negative 1 times 0 got 0, minus a negative 24, so that's plus 24. Here we had negative 1 times 9 is negative 9, minus 30. Okay, then we multiply 2 times 36 was 72, 7 times 24 was 168, we're subtracting that. And then a negative 39 times a negative 3 is plus 117. So you can see that there's a lot of arithmetic again that we can get lost in pluses and minuses. Be careful. Be careful of your pluses and minuses, be careful of your arithmetic.
And
Right.
your order.
And your order, yes. Okay? I want everybody to do number 2 at the bottom. Evaluate the third order determinant. -2, 3, -1, 5, -3, 8, and 4, -6, -5 using expansion by minors. And as long as you got the formula up here, it shouldn't be too difficult to understand how to do it. It's just getting lost in the process.
Book, like, didn't show us the crossing out thing. So
Yeah,
I was
it's
like,
at the
oh, why
top
is
of
it so
page
complicated?
195.
Oh wait, it was okay. So I didn't see that. I was like, oh, why is it so complicated?
Yeah.
Now it's so easy.
Yeah, if you can think in terms of the crossing out the different things, then that second order determinant, the minor, becomes very obvious. And we're going to try to do it without the help of the guide up here. Once you are done, you can check with my work up here, see if you came up with the same thing. If not, either you're wrong or I'm wrong or we're both wrong.
You added 6 and 8, something so close to 3 times.
Negative
first one.
48.
Ah, okay. Awesome.
Even then you added.
I added instead of multiplied. Okay, so this should be,
That's correct.
No, the other one.
oh, the other one. So this is 15 plus 48, right? So it's 50, so this should be 63 here, which should give us negative 126. So that's going to be Is that correct now? No, still incorrect?
The negative 26 plus 1 plus 18 is 63.
This is 62?
63.
Oh yeah, I think I subtracted rather than added there. Okay, so 126, negative 126 plus 171. This is where calculators come in handy. That should be what? 45. Positive 45 plus 18 is
61.
positive 63.
Oh.
Right? Am I right now? Yeah.
How did I get 27?
Okay, did everybody come up with that? Realizing that this is a positive, but the positive of a negative is a negative, right? And this is minus, and this is plus again. Plus a negative is minus. And yeah. So you got to watch the positives and negatives. And when there's a 1 in front, we can just drop the 1 out, right? Because 1 times anything is root of that. Okay, let's look at the second way. That's one way to do a third order determinant. There is another way. Okay, you need to learn both ways, and then after that you can choose which way you want to use. The third way, or the second way, is by using diagonals. Okay, so when we use diagonals, let's go back to our A, B, C, D, E, F, G, H, I. Okay, so we got our third order determinant here. And now what we're going to do is take these two columns and we're going to add them out here. So we're going to add another A, B, D, E, G, H. I just added these two columns out here. You ready?
Yeah.
Okay. Now, let me move to a different color here. What we're going to do is go diagonal. So we're going to go diagonal down like this. And we're going to multiply A times E times I. A times E times I. We're going to go diagonal down like this and then we're going to add those. B plus F, or times F times G. A times E times I plus B times F times G plus C times D times H. You see why we have to add 2 rows there, so we can get 3 factors in each of those. Okay? Everybody with me so far? Okay, now we're going to start in the lower left and go up. G times E times C. H times F times A. And I times D times B. Okay, now, there are a couple ways in the book. What they do is they bring these down and just subtract each term there. The way I prefer to do it is so that we can just remember to add top and bottom. Okay? But then we're going to subtract this from what's down here. Does that make sense?
That's the same one.
That's the same thing.
Yes.
I'm distributing out the subtraction sign. So now we're going to go minus GEC plus HFA
Oh,
plus IDB. We're going to subtract this whole sum up here. Okay, what they do in the book, which is the same thing, because we can distribute that negative sign, if it's easier for you to remember, is we can just say minus GEC minus HFA minus IDB. Do you see they distribute out the negative sign? I undistribute the negative sign. Do you see that? How that's the same thing? And I prefer just to add down here, add up here, and then subtract this from down here.
That's why.
Instead of subtracting one term at a time. Okay? You up with me? You ready to try one of these? Now in the past, it seems typically kids prefer the diagonal way. But I'll leave it up to you. You do have to learn both ways, but after we learn both ways, you can use whichever way is easier for you to remember. Okay, so let's look at negative 1. Can you read that to me? Negative 1.
3, negative 3, 4, negative 2, negative 1, and 0, negative 5, 2.
Okay, so what am I going to rewrite over here?
The first two columns.
First two columns. Negative 1, 4, 0, 3, negative 2, negative 5. Okay? Now, just to keep consistent with what I did before, using the same colors, we're going to go down like this. Negative 1 times negative 2 is?
Negative
Oh,
2.
negative times a negative is a?
Positive.
Okay, positive 2 times 2 is? 4. That's what I said. It's real easy to get lost in the pluses and the minuses, the positives and the negatives, and in our addition subtraction. You saw I got lost in the last one there, adding instead of multiplying. Real easy to get lost in the arithmetic. So check and recheck what you're doing on these. Oh, this one's easy because anything times 0 is? 0. So it's great when you got a 0 in there.
Yay.
Okay, how about this one? Negative 3. Let's do the negative 3 times the negative 5 first, because that's going to make it a.
15. Positive.
Positive 15 times 4 is?
60.
Who said negative? Negative times a negative is a positive. Positive times a positive is a positive. There we go. Okay. So we're going to add these together. Okay, and we get what? 64. We done? No, we got to go up also. Okay, so we're going to go this way. Oh, good, we got a 0 in there. That's going to be what? 0. Okay, now we got 5 times 1 times 1, which is?
Negative 5.
Okay, yeah, that's 5, and then negative times a negative is a positive times a negative is a negative. So, odd number of negative signs, it's going to be a negative. Even number of negative signs, it's going to be a positive. Right? Okay, so that is negative 5 for that one. And let's go the third one. Do we have any negative signs in there? Okay, 2 times 4 is,
8.
times 3 is
24.
24, okay? And the way I like to do it is just add these together. 0 minus 5 plus 24 equals what?
19.
19. And now we're going to take this total and subtract it from this total.
45.
Put this back in black because that is our determinant. Is that what they came up with in the book?
Yeah.
It's nice when we come up with what they come up with, right? Okay, try evaluating the third order determinant at the bottom of the page there. See if you and I can come up with the same things. I'll try to keep my arithmetic in check this time. Or maybe people can earn more chocolate.
Yay.
I kind of like it when I make mistakes, then you get a chance to earn chocolate.
Five times 7 times 5 is 175.
Yes.
Ah, cool.
So the answer should be 134. It's 10 more.
So this is 175.
171 minus 37.
There we go. Got it? How you doing, Jenny? Did you get it? A lot of arithmetic to get lost in, isn't there? Okay, it's kind of like doing the, what did we do last chapter with all the arithmetic? The three
Finding out
variable,
the variables.
yeah, the systems of equations and 3 variables. By the way,
That's crazy.
do you know what a very practical application for matrices is? Solving systems of equations. That's why we're learning how to do this. This is using matrices as one way to solve systems of equations. And they're both very arithmetic intensive, okay? Which is good practice for your arithmetic. But you have to beware.
So algebra.
You have to beware, okay? Okay, let's look at another application of this, a real life application. Let's read at the top of page 197 there. Sarah, could you read that?
One very useful application of determinants is finding the areas of polygons. The formula below shows how determinants can be used to find the area of a triangle using the coordinates of the bases.
Okay, so here we have a triangle on a coordinate plane. And it has point AB, point CD, and point EF. Okay, so who remembers what the area of a triangle is?
1/2 base times height.
1/2 base times height, correct? Okay, so what we're going to do is the determinant is the base times the height, and we have to take half of that. Okay? So if we have a triangle there, it shows you AB is one of the area equals 1/2. AB is one of the coordinates. And what do we use for the third number here? 1. CD is another coordinate. And EF is the third coordinate. Got it? Okay. And so let's see how that applies. That is your key concept on 197 there, area of a triangle, using third order determinant. Okay, so Sarah, could you read the real world example there?
The local radio station in Kentucky wants to place a tower that is strong enough to cover the cities of Galvington, Utility, and Lewisburg. If the coordinate grid is in which one unit equals 10 miles is placed over the origin.
Placed
over
over.
the map of Kentucky with Galvington at the origin. The coordinates of the three cities are 0, 0, 3, 0, and 1, 2. Use the determinant to estimate the area the signal was covered.
Okay, so Yelvington's at 0, 0. How far away is Utility?
We don't know.
Yes, you do.
About 10 miles.
1 unit equals how much?
10 miles.
And Utility, what's the coordinate of Utility?
3, 0.
3, 0. So Utility is how far away?
30 miles.
30 miles, right, okay. Because 1 unit equals 10 miles. Okay, so let's do this. The area is going to equal 1/2. Okay, what's coordinate A?
3, no, 0, 0.
0.
Okay, what's coordinate B?
3.
3, 0.
Coordinate C?
1, 2.
It's what?
1, 2.
Okay, now, do you want to use expansion by minors or do you want to use diagonals? Diagonals. See, I told you it was most people's favorite, using diagonals. Okay, so what do we do out here? Especially with zeros and ones, it's going to be pretty easy using diagonals, right? 0, 0, 3, 0, 1, 2. Okay. Now, I'm not going to color code this time, but that's going to be what?
0.
That's going to be, and that's going to be, okay? Let's go this way. That's going to be,
0.
that's going to be,
0.
and that's going to be.
0. So, it's 6.
No, 0.
No.
Oh, 0, yeah.
The answer is 6.
Yay!
But
Times 1/2.
oh yeah.
Oh, yeah, we have to go times 1/2, right? 6 times 1/2 equals 3. Okay, now,
Which is 30.
is that what they got in the book? Oh, they did. Okay, now remember, one unit equals 10 miles, right? And when we're, so 3 units is going to be how many miles? Times 10 is going to be 30 miles, right? But what kind of units are we looking for here?
Square miles.
Square miles. So actually, it's 3 times 10 squared, right? Because they're square units. So you got to be careful of that. Because we're looking for 10, we're looking for area, square units. Okay? So 3 times 10 squared is 3 times 100, which equals what? 300 what?
Square.
Square miles. Okay? Your assignment. Page 198, 9 to 25 odd, and number 26. Number 28 is extra credit. 26 is just like our example that we just went through. Okay? And 28 will give you more practice at doing stuff like that.
Do you want us to write down a starting matrix?
Yes, please. Write down where we're starting.